Hi everybody, it's me, Lady Ada, at my desk of Lady Ada, but I'm not doing electronic design right now. I'm hanging out with Scott. Scott Tan-Newt is here visiting us from the Pacific Northwest. Thank you for coming.
Thank you for having me.
He's not a hologram, he's real.
I'm real.
And I thought we would spend a few minutes while we're hanging out, and we have babies, so we're not doing much engineering, but we are chatting about past and future of CircuitPython because Scott is the lead of the CircuitPython project, bringing this to life. CircuitPython.org is behind us if you want to learn about it. So first off, let's just do really quick intro. So what do you do on CircuitPython?
Yeah, so I'm Scott. I go by Tan-Newt online. I think I fell into the lead role.
We were the only ones.
Because I was the only one. So I don't know, 8 years ago, I was going on show and tell, and I was like, I'm looking for a job because I was coming to an end of my work hiatus, and they said, hey, we have this project for you, and it's MicroPython on our boards. And I was like, I've never heard of MicroPython, but I love the Python language, and I just discovered that I love embedded stuff. So kind of picked it up. I dropped what I was doing. I was super excited, and really taken this was MicroPython and kind of tweaked it for Adafruitizing it, I guess.
Yeah, and we came up with some API decisions, and eventually we were actually doing MicroPython. We decided to fork because you were making so many decisions.
Yeah, and I was doing a lot of code, right? There's also this practicality of getting it all upstreamed, and I figured we would do what you had done with Arduino, which is bring all these libraries kind of into this ecosystem that you built. And we had to build a strong Python foundation for that. And over the last 8 years, which is just insane to me, we've proven out that I think the decisions we made in that first year were quite good.
Yeah, I really love a lot of people use CircuitPython. We have it available for almost every board we have. We have a lot of chip families supported. So it's enough people have a choice, right? They can use Arduino, they can use whatever SDK the chip comes with, whether it's NXP or Microchip or Pico or whatever, or they can use CircuitPython. We also do upstream contributions to MicroPython. So we're actually going a little closer together. You had actually had a chat with them, the developer. You have a chat with them almost every quarter, right?
Yeah, I'd say it's about every quarter. We want to see what they're up to, and from time to time we take the changes. So the core Python part of CircuitPython is shared with MicroPython, and we'll let them know oh, we did this technique or that technique, and we actually tend to be a little bit more aggressive in the things that they're doing.
Yeah.
So for example, in CircuitPython 9, which came out in I think April of this year, they introduced this split heap idea.
Yeah.
Which they did only for expressive chips because you have the internal RAM and the external RAM. And I was like, you know what, we should do it just on all of it.
Okay.
And so
but they
kind of went whole hog on it, and they like to see how to go.
Yeah, they do. They pioneer maybe, and then we kind of come in and we're like, okay, let's also do something different. So it's really good give and take. And speaking of the last year, Python 9, I thought we'd spend a couple minutes just chatting about, now that we've introduced, and everyone now is your best friend, what happened in the last year in CircuitPython and in MicroPython, and then we'll talk afterwards about what we want in the future, because this is winter. It's time to think about the new year.
Yeah.
So last year, what was some stuff that we did that you thought was cool? USB host was one of the things, right?
Yeah, I was.
So what is that?
I was reviewing it because I have a bit of a newborn baby brain for things, but I was taking a look at our releases, and we did USB host in a couple ways. We polished it up on the IMX chips, which have it natively, and then we also did USB host support on the RP2040 using the second core and the TIO. And then we also did it with the Max 3421 chip, which is an external SPI chip.
Which is an ancient chip, but it works really well, and it's fairly inexpensive. And we got it into Tina USB.
Right.
USB host was one thing. You also did that camera input. We did the video input mode.
No.
What was the video output mode? Wait.
Video out. Yes, video out was one. I think we can actually do display stuff up the USB link now.
Yes.
I was thinking of
you can now we have DVI output on RP2040
and the 2350
and the 2350. So you have video, and then we also have video upstream into computers.
Yes,
so you can take, we do screenshots. Yeah.
I've been meaning to use it.
You really want to do screenshots.
Yes.
And they also have like native keyboard support with USB hosts. So you can actually like
Right.
type on it. You can have a little computer. Yeah.
And I think that's something. We'll talk about a little bit, the future in a little bit.
Yeah.
You know, a lot of our work is also characterized by chips. And so the RP2350 was one of those that came up this year, and really we were stoked. It has double the RAM, which is usually one of our constraints. And then the Cortex M33 with built-in floating point means it goes much quicker than the M0s.
Yeah.
We're still like working on leveraging both cores. And hopefully that's something we'll be better at in the future. Sorry.
Okay.
I like to look forwards.
What else did we do? Yeah, I know, but we actually also look back.
Yeah.
We like look at all these successes. We did the floppy disk stuff that Jepler worked on. We did lots of libraries, of course.
We got
Synth.io.
Synth.io has been just blossoming.
Yeah.
Kind of Jeff has been shepherding that, but also some other community members have been helping, which is awesome. And you know, that's one thing I wanted to bring to the project from the get-go, is really supporting our community members as well. And I think I can't think of any project where it's really gotten hung up kind of like because we weren't responsive.
Yeah.
We really do want to be responsive. It's usually, from my perspective, it's usually the opposite. It's usually we're responsive and then the other person.
You also did a lot with workflows, Bluetooth, and that's where you were before you went on leave. You were like working on Wi-Fi workflow stuff.
Yeah, so Wi-Fi workflow is like, I was thinking that has been my CircuitPython 2020 whatever for like years now.
Yeah.
All the different workflows, and to some degree, I think we're kind of done.
Well, yeah, we also have the web editor, which we worked on.
The web editor's got a lot better
integrated into the CircuitPython.org, so people can now edit, upload, download files. We also have ESP32 support because we have the Wi-Fi workflow. So we have Bluetooth, serial Wi-Fi, just kind of a more integrated way of using the boards. And we have support for like Thonny and other editors, but we thought it would be good to have a web serial.
And I think, let's be super clear, because for a while in CircuitPython, we said we were only focused on USB.
Yeah.
That is not true anymore.
Yes.
We've gotten rid of that. So serial over USB is fine. Straight serial is fine.
Yeah.
Bluetooth, BLE, web workflow, which is over typically Wi-Fi. And then the USB workflow that we've kind of like branded CircuitPython along with. But we branched out. I think the other workflows are really good. I had forgotten that we had done BLE support on Espressif chips this year.
We did this year.
And that's huge, because now you have something that can do Wi-Fi or Bluetooth at the same time, which is great.
Yeah, so really cool thing about the chip. And of course, they're inexpensive and they're very popular.
Yeah.
There's so many dev boards that use them.
Yep.
More chips, of course. We added more Espressif chips, like the C6s.
Yeah, so we're up to date on their IDF.
I know we also had ESP now. Somebody contributed it.
Yes, I think it's broken.
Oops. Oh well.
I think I might have broken it. Something happens as we upgraded from like IDF 5.2 to 5.3.
And that's another thing, a lot of it, as a project gets into a mature phase, which, I feel like 8 years is a mature phase for CircuitPython. No, I'm serious. It's like you get to a point where it's like you're actually spending a lot of your time just doing maintenance and updates. So one of the things that we did a lot this year was updating SDKs and build platforms. Like I know, I actually can't even keep track anymore. So you move different build systems back and forth in Espressif, and having something that can build for Raspberry Pi using they use CMake, and then for Espressif and they use their own make whatever. And there's somehow so many make files.
People tend to wrap CMake and other things.
Yeah.
That's typically Python.
Yeah. So I think you worked a lot on the build system.
I'm planning on it.
No, you did work this year on
the
system. Yeah, you don't remember. Because with the IDF, I remember to get 5.3 or whatever.
Yeah.
Well, I have to restructure some stuff. And
okay. Yeah, there's usually maintenance things. Because we kind of, poke it. And we don't use it the way they expect us to. One of the a primary challenge of CircuitPython is that we build on top of a lot of different vendor SDKs.
Yeah.
Where the vendors would really like you to just use their chips and then you stay within their ecosystem.
Which has pros and cons. I mean, we've historically done that. So for example, Espressif you said they have their integrated development system, and then Raspberry Pi for Pico, they have their integrated development system, and then for microchip,
Those are probably the best two.
the biggest two.
They're the best two. Like the 2350 was pretty easy to adopt, and then like all
Right.
of the other espresso chips were relatively.
But there is this like huge like effort in like the NXP chips, like getting them going.
Getting new vendors.
Getting new vendors is a lot of work.
It's a lot of work.
And then sometimes even adding chips within that from that vendor can also.
Well, sometimes vendors are like, we're just going to have a new SDK.
Yeah, I mean, which we can talk about as we transition. Nordic, they've moved away from having their SDKs.
Yeah.
They've moved away from into supporting Zephyr. So I think a lot of, and it's tough. Like every time we add a new board family, not a chip, but a family of boards. Like we were talking about adding, Renaissance or like doing more with NXP. It's like, it's a huge lift. And
we should give a shout out to Scilabs and Analog Devices who have
contributed
yes to CircuitPython.
They did add their own.
So we're happy to support people.
It's good. Another reason why we have TinyUSB support is something that we care a lot about. We push vendors to use TinyUSB because TinyUSB is it's well supported within CircuitPython now. And so we can do host and high speed now and USB client, and you can do MIDI and we don't have to worry about everybody's USB stack being neurotic.
Different and broken.
And broken in different ways.
Yeah, and like that was a bet we made years ago now to say like the only USB stack we're gonna use is TinyUSB, and because USB is core to kind of the things that people want to do with CircuitPython.
Yeah.
I think it's really just benefited us that like you don't have to worry when you do a new port, you do a new chip, you don't have to worry about bringing all that stuff into it.
Yeah. Okay. So speaking of SDKs, so there's a lot of chips coming out this year. Let's talk about the next year.
Yeah.
That's what we did. And that's actually a lot, by the way. Like a lot of stuff, and then not including all the bug fixes and the updates and
making sure
adding and making sure, and all the functionalities and all the libraries and the little details.
Yeah.
Let's talk about the next year. So new chips we're excited for.
Yeah, I think you were telling me that you felt the chip shortage is finally over.
Oh, it's like it's like over.
Like new chips.
Chips are coming, which is like it was like just catching up, and now I'm starting to see new stuff. Like we did INPI and we covered the NR54, so that was like announced 2 years ago. But obviously they're like they were unable to release it. The ARPA 2350 is doing great, and you're also seeing that in the day sheet they mentioned like, oh, we're gonna have like other variants available. From Espressif, the P4, which you already actually you got that started.
It's working. We got USB going on it.
Yeah, it doesn't have
tacted
wireless, but
right.
You got
but it's dual 300 megahertz RISC-V cores.
Yeah, which is interesting. Like the chips that are coming out now are just beasts. Like it's.
We're in Moore's Law. This is kind of the way it's thought of.
Yeah, like, it's really coming for the microcontrollers now.
Right.
So when we were starting out, we had the CMD21, and I knew it was a kind of a smallish chip, but it was still like, well, 32K of flash, 32K of RAM, but now, and an M0, now everyone's new chips are basically, for lack of a better term, like they're crossover processors. These are, they're M33s or better.
Right.
These are chips that could run Linux. If they had a memory manager, they could run Linux. They are, serious chips with a lot of flash, a lot of RAM, usually external RAM memory managers. So often they have display managers. They have all the peripherals built in, multiple USB.
Right. Bringing features from those chips that run phones.
Yeah.
Any low-end phones, not high-end phones, but like bridging the gap from a low-end phone into the microcontroller.
Dude, my like washing machine text, like it's like you have to. It doesn't let you not, and you can upload ringtones to it. It's clearly running like a pretty serious operating system, and also
it has probably multiple micros in it.
Probably, yeah. And as you mentioned, also multiple cores. Like it's really common now to see chips where there's, an ARM like A7 or whatever. I'm not with the right chip part number, but they have a sub chip that's also an M33.
Right.
Or they have RISC-V. They sometimes RISC-V cores.
Yeah, now we're getting dual architecture.
Multiple. It's happening a lot.
Different versions of ARM, but ARM and RISC-V.
Yes.
Yeah.
And the peripherals are getting complicated. And one of the things we were chatting about is how are we going to add new chips without wanting to die?
Yeah, without spending all year on it.
Without spending all year on it. And also, here's another thing. We love Scott, but right now Scott's the only one who can, other than external firmware developers for other companies, who can add a new chip family. And we want Scott to have a life and not be just constantly adding new chips. Scott should be working on fun stuff.
Yeah, I'm also taking some leave next.
You're also taking some leave. So we want to like get set up. And you also did Circuit Matter, which, you know, we're still working on, and will Matter integration. That was actually a couple months of your time.
It was.
So, you know, we were chatting about maybe using something like free RTOS or Zephyr, or what was the Apache one? There was another one. Minute.
Yeah, where Nimble project came from.
Yeah. So what's your thought about that? Because we're starting to dabble in Zephyr land.
Yeah, so I'm exploring Zephyr,
which is a real-time operating system that is kind of becoming like the de facto standard.
Yeah, for sure.
That everyone is contributing their chips to.
Right.
Okay, so before we get into why we're using Zephyr, let's explain
why we're thinking
of using Zephyr.
Trying to prove it out.
Right. So Zephyr is a real-time operating system,
right?
But it's also like a build platform.
It's a lot.
It's like a whole
big project. Imagine a bunch of Linux developers making
Arduino.
Yeah.
Basically. And the idea is that you could move from chip to chip very easily because a lot of chip manufacturers like Analog Devices, which is also Maxim, which is also Linear, and even Espressif and Microchip/ST and Atmel, blah, blah, and NXP are all contributing their board definitions in the hopes that people will, once you learn Zephyr, you can then use their chips. Because most of these chips, to be honest, they tend to all be ARM cores. Yes, there's slightly different variants. And there's not like new peripheral ideas. It's like I2C, UART, SPI. So they're trying to kind of unify it a little bit like Arduino, but more powerful.
And there's a lot of things on top of that, like networking, Bluetooth.
Yes, well, as you said, the wireless stack is managed for you, which is like amazing. All right, so that's what Zephyr is. And it's a nonprofit.
Yeah, they're run by the Linux Foundation.
It's a consortium. Okay, so why are you looking at it? Why not something else?
Well, you said,
what are you thinking?
Yeah, you just asked me a couple weeks ago, but like, hey, like, how can we make it easier to port to a new board? And I was like, you know what? It's in the same way that we want this memory management thing across all of our boards. We've been saying like all of these new chips have multiple cores, and to do cores well, we need a real-time operating system which manages.
And not DIY it.
What's running on different core? Yeah, not DIY it. And so in my mind a lot, I was like, oh, we'll use FreeRTOS that Espressif uses and their SDK. We already work with that. Let's just do what we kind of did before and just use it everywhere.
Yeah.
But then you had this comment about it. I chatted with somebody at Espressif who was like, yeah, we officially support Zephyr now with Espressif, and you can actually get some NRF54s now. And so
Nordic is also like completely new to Zephyr, and they're like, we're not
on that.
Well, they're like, we're not supporting the old version because with their chips, they have Wi-Fi chips and Bluetooth chips. The wireless stacks, it's so complicated to manage a wireless connection in a single thread. You really need it.
Right.
You need to be like a computer where it's like, you tell it the SSID and the password, or a collection of SSID and password, and you're like, just make sure I can send packets.
And it's on a second core, right? Like they're using it for managing multiple cores and different cores of different architectures.
It's a lot.
It's a lot to do, and they've thought a lot.
And the authentication.
Yeah, all the TLS stuff.
Yeah.
Yeah. So thinking to the future chips, NRF54, L series, H series being interesting.
Yeah.
The ESP32P4 being very interesting from the high performance. It's also dual core.
The Renaissance chips.
The Renaissance, the R8.
Maybe NXP. We want to do more NXPs, and maybe this would be another excuse.
Well, yeah, like so. Okay, we want an RTOS. Okay, we want a newer Nordic Bluetooth stack.
Yeah.
Those two things come along with Zephyr. I've had criticisms about Zephyr because there are the same criticisms I have for most vendor SDKs, which is we're very, very dynamic in what we want to do.
Yeah.
that's a challenge for us to use other code that's written for it. So like
Yeah.
Zephyr will, or a vendor SDK will assume that you want to pick what pins are going to do at compile time,
Yeah.
because compilers are great at making your code small for one
Yeah.
case. Whereas like we're not going to do that.
Shit, like you don't accidentally, like Espresso actually added this recently where once you set a pin to be an output, you cannot try to use it as an analog input. It will actually just like hard fault. It'll say like, I'm not letting you do that.
Yeah.
You have to
Right.
decide what you want the pin to do. You can do it dynamically, but you can't change it on the fly as easily.
Right. So after we had that comment, I was like, like let me see how it would be to move to Zephyr, and move to Zephyr in a way that like we actually move all of our existing stuff to Zephyr too.
Yeah.
I think there's an asterisk there that like if something really is not in the Zephyr land, we may like just kind of leave it in maintenance mode.
Yeah.
With our current setup, so we won't break the other ones as we move everything else. But
So does it mean we're not going to
that's
have
one thing.
dynamic
No.
pin changing, or what
So-
are we going to do?
So do what we do with SDKs, which is we use the parts we want, and we
Yeah.
do the parts that we need on our own.
Well, you can always, it's still C, right? It's still C, C++. You can always call the underlying SDK.
Yes, and
Like in Arduino.
it's also open source.
Yeah.
So, for example, the Espressif IDF, we carry a few patches on top of that for ourselves. We can do the same thing with Zephyr.
And then they can get integrated, hopefully.
Yeah. They're pretty easy to just move on to the next version,
Okay.
because they're pretty minor. So in the worlds where, or in the cases where it is actively trying to prevent us from doing something, we can go in there
Of course.
and hack it. So
But what are you getting with Zephyr that's like, you're like, this is worth it? Like what's worth, like this effort, but what are you getting that you think is?
well, one, we get it easier to bring up new manufacturers, new vendors that are supported by Zephyr.
Even if it's like fixed GPIO,
So I want
just to get it like running.
Yep. Just like a baseline, the build system is part of it. That's always hard to manage. So getting it just like doing the same build system that Zephyr does from the outside. And I was just doing it, and they have West debug. They have this West command.
Yeah.
Because Zephyr is a
West Wind, yeah.
So they have West and then bit debug, and it just works. And West Flash just flashes.
And they manage that for you. So it's like
it's all they track all the tooling and stuff. Like I'm not using their CMake to build CircuitPython stuff, but they give me all the flags and the compiler and all that. They manage that, so I don't need to bring it with me at all.
Okay. But also, it seems like it's kind of like, look, if Nordic has decided not to manage an SDK, eventually, I think a lot of chip companies will say, "Why manage an SDK when you can just?"
Yeah, well, Nordic it's kind of like they have their own distribution of Zephyr. They don't.
Yeah.
There's support in upstream, but they also have a downstream version that they maintain, which is like
It's just gonna be fun.
we'll see.
You'll see.
We'll see how that goes.
So you just started. You only done that for like a couple weeks now.
Just a couple weeks. I'm like, I've got it building. I've got it running.
Yeah.
I do want to. I ran into a thing where they assumed that I wanted to do blocking read and writes on UARTs, and I was like, I don't want blocking. So now I've got to dig
in
a couple layers level deeper. But
or maybe some people watching are like into Zephyr development. They can join us. We have Mondays. The CircuitPython meetings. We're on Discord.
Yep, Discord.
Discord.
adafru.it/discord to join there.
Yeah.
A common Bluetooth stack.
Yeah.
How nice would that be? We have 3 right now, I think.
Oh, yeah. Especially if we could share, like, because we have. What's funny is it's like we have the same API in the end. It would be great if we had the same API in the beginning, instead of like different stuff that we then funnel and squish into like our match. Oh, do they have Bluetooth Classic?
They might.
Should be great.
I don't actually know.
Because usually, again, it's underneath. It's the same.
Or it's one or the other. Yeah.
Oh, do they have cellular support?
They do.
Ooh, that would be.
Yes.
So that sounds so.
Yeah.
Just doing the AT command management or the PPP management would be so great.
And like their build system also can manage like multiple images for different cores and stuff.
Yeah.
So like, you know how we have airlift?
Yeah.
Like we could actually like figure out how to have it manage the airlift chip too.
Yeah.
So you just flash one thing. So I think we might have UF2 improvements to go along with it.
Yeah.
So that we can do that.
That'd be all right.
It solves a lot of the problems that we have, even though it gives us new ones.
Yes. That's like the developer's quandary. Like,
Yeah.
one problem and one. Yeah, so that's coming up. So that's the beginning.
We don't want it to take things away from CircuitPython. We want to make it easier to add things.
Okay. And then we're doing also a call to action for 2025.
Yeah, so soon we're gonna do CircuitPython 2025. Maybe by the time this video goes up, I just ask for assets. The holidays are a great time to reflect on how the past year has gone and how you want to refocus for the coming year. And what we do every year is we say, hey, community, not just us, but everybody involved in CircuitPython, we want to hear your ideas and we want to just see where you're at. What projects do you want to do it with CircuitPython that were hard or impossible? What things do you think that CircuitPython can make easier?
Chips you want to see. Bugs you maybe want to bump up and try to get
Get
fixed.
squished.
There's 1,000 open issues.
Maybe you're using ESP now
Maybe,
and it's more important.
or maybe you want to actually contribute. Some people are like, I want to join in.
Yeah.
And we can,
We are.
yeah, we'd love to get you started. And there's code in Python and C.
Yep.
And yeah, exciting. Yeah, I'm looking forward to it. I think there's a lot of good stuff. I think as we head into this next year and we're heading towards the 10th anniversary of CircuitPython.
Blow my mind.
Yeah, but it's like, look, it's still, the project is living. It's good.
And I think our vision has stayed the same. Like make it easier. Like we have on the site, it says the easiest way to program microcontrollers. I think we still have lived up to that, and that's still our focus.
I like how I love how it's just like I can get people going so fast.
Yeah, I was talking to somebody today about I'd really like to dive into code, and you plug it in, it shows up as a drive.
Yeah.
It's really easy. We have young children. I think a lot about will my kids' first electronics experiences be?
Yeah.
And they won't be internet browsers, right? They're going to be something slimmed down, and how does CircuitPython fit into that?
Cool.
So I think we've gotten this far because we've had this vision.
Yeah. Oh goodness.
Yeah,
so
you said 10 years.
It's coming up. So yeah, people, you all have ideas, post them on social media, tag them. Maybe we'll have
#CircuitPython 2025.
2025. We're on the Skeets, the Mastodorks.
Yep, we'll have the CircuitPython 2025 at adafruit.com email. So just drop that email. It goes to Phil and I, and then we'll blog it up so that we can have
comment on this video.
A list.
Yeah. All right, cool. We're going to keep hanging out. Our babies are about to wake up from the naps, so we got to go. It was good hanging out with you, Scott. Chatting about the past and future of CircuitPython. If you all have more questions about CircuitPython, where it's coming, where it's going, put them down there.
Yeah.
Thanks, everybody.
Talk to us on the Discord.
And have a great holiday.
Happy holiday.
See you before then.